What's up, everybody? So in Algebra 2, we've solved quadratics with x squared, and we've solved cubics with x cubed. And so we took the square root and we took the cube root. Today we're going to be solving some equations with exponents that are bigger than 2 and 3. So when we have problems like x to the 4th, x to the 5th, and x to the 6th. So I'm going to get right at it because we know the general strategy, which is to just undo it and try to get rid of what is already in the problem. And then we'll talk about the difficult parts as we get to those. Okay, so if we take a look at the first problem here, we've got 3x to the 4th. We're not even worried about the answer over there, just how do we get that x by itself. So we're just going to go ahead and undo it. So we're going to go ahead and divide by 3 on both sides. And that's going to bring us down our x to the 4th. And 48 divided by 3, grab a calculator if you need it. That gives us 16. So at this point, we're solving just like we do with square roots and squared, and just like when we had cubed and we used cubed roots, here we have a 4th power. We're going to use the 4th root, right? So I'm going to draw that square root on both sides, but I'm going to make sure that it is the 4th root, so that little 4 exponent sitting on that ledge, that's going to go ahead and cancel out the 4th power with that 4th root. That gives me the x all by itself, and now I need to type in the 4th root of 16. If you have a TI-83 or a TI-84, you can head to the math menu. I like hitting the 4 first, the root. I hit 4, go to the math menu, and then scroll on down. You'll see a root that has an x with it. You can type any root that you want. So you'll see further on the worksheet, we do 5th root, 6th root, and 8th root. So you can use that. If you're on Desmos, you're going to head to the functions menu, which is over to the right. And then under that, you're going to hit miscellaneous menu, so functions, and then miscellaneous, and you should see a square root symbol with a little n. In that n, you can type in any number. So as I'm typing in the 4th root of 16 over here, we get 2. If you need any help with that, ask me on the side. I can help you out when you're in class, or shoot me an email. I can screenshot it or something like that. Cool, so we just undo, 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 undo. How do we get rid of 4th power? We take the 4th root. Got some Imagine Dragons going on here with the song Roots, and that's what we're doing. Going back to the roots, we're just taking some roots. Cool, so I made the second problem very similar to the first one, so we can think about the same strategy. I just changed a couple of the numbers, but we're really just trying to get x by itself, so get rid of that extra junk. Go ahead and divide that 3 out of the way. All right? So once you do that, we've got our x to the 5th all by itself. 96 divided by 3, that should be in the 30s, and that would be a 32. I'm just double checking on the calculator so I don't lead you astray. Cool, at this point we're solving for a 5th power. We're going to go ahead and take the 5th root. What else do I got here? Let's do some Zach Brown Band roots I'll play in the background. We're going to go ahead and take the root on both sides, but not the square root. We want to make sure it's the 5th root. When we go ahead and take the 5th root with the 5th power, that goes ahead and cancels out. That gets us our x all by itself. When we take the 5th root of 32, we can go ahead to our calculator, hit 5, go find that root button, and type in 32. Cool, and we get x equals 2 again. All right, so here's the thing. I lied to you already. Okay? I just wanted you to think back when we solved for quadratics, and when it was x squared, we should have 2 answers. But when it was x to the 3rd, we did not have 3 answers. And that's because for x to the 3rd, there's only one number, right, that you can, like maybe a positive, that you can go to the 3rd power and end up positive. And then there's only one negative number that you can go to the 3rd power and end up negative. So what we have to think about is anytime we have an even exponent, that you could put in a negative answer as another option, right? So when we look back at that first problem, I think it's great if you went ahead and you tried to plug your answer back in and double check. But if we plugged in 3 and then plug in that 2 as our answer to the 4th equals, does it equal 48? I don't know. So we would have to go ahead and do our exponent first. So 2 to the 4th, that gives me 16. So 3 times 16 equals 48. Cool, so that was one of the answers. I want to know if there was a second answer, like is it okay to plug in a negative 2? Well, what happens when you do a negative number to an exponent when it's an even amount of times? Negative 2 times negative 2 is going to pair up and make it positive. And then another negative 2 and negative 2 is going to pair up and make it positive. So I lied to you in the first problem. We were good so far, we just weren't totally good yet. So anytime that you have an even exponent, make sure that you're writing your two answers there. So we got x equals 2. We should also have x equals negative 2, right? Now, does that work for our second problem? No, it doesn't. We don't have a second answer, because if we would plug a negative number into the 5th power, because it's an odd amount of times, we'd still have a negative in the problem. Hopefully that wasn't too fast for you, but you can let me know. I can always help you out on the side. So we're going to go ahead and dig into that a little bit more, and we see that number 3 starts to get a little bit more complex, but we're still just going to undo. So we go ahead, we subtract 4. Cool. That gives us a decimal, 0.2 x to the 4th, and that is equal to 125. At this point, we're going to go ahead and divide that 0.2. We're just getting rid of all that extra junk and trying to get that x by itself. Cool, we are really close to getting that x by itself. I'm going to need my calculator for this one. 125 divided by 0.2, a decimal. That takes us upwards when we divide by a decimal. And now we're going to go ahead and take that 4th root. When we go ahead and take the 4th root, be aware, are there 2 possible answers? Yeah, because this one is even. So I want to go ahead and make sure I have 2 possible answers once I'm done with this. I'm going to go ahead and take the 4th root on that side, which will cancel out. And then I need the 4th root on this side, and I need my calculator for that. 4th root of 625 gives us an answer of 5. Now remember, there's 2 solutions there, because it's an even exponent. A positive answer would work, and a negative answer would also work. Sweet. We go to our next row, and we got some parentheses here, but we're still just going to undo the same thing we've been doing the whole chapter. I'm going to grab, this song was on the radio a couple years ago, No Roots by Alice Merton. Well, yes, we are going to take the roots, Alice Merton, but we're going to go ahead and get rid of that extra junk first and go ahead and divide by 2. Cool, that brings us down to our parentheses, x plus 1 to the 6th power. We cut 128 in half, and that gives us 64. And now we've got the 6th power. Cool, no worries, we go take the 6th root. Now, remember that's even, so we got 2 possible answers when we're coming out of this problem, whatever happens. 6th power cancels out with the 6th root, and we got our x plus 1. We take the 6th root of 64, 6, head to that math menu or that functions miscellaneous. The 6th root of 64 gives us a 2. Now remember, there's 2 possible answers, so the other answer could be x plus 1 equal to a negative 2. Cool, welcome to middle school math. We go ahead and subtract 1 from both sides. Boom, undo it. There's one of our answers. Notice anytime we have parentheses, it's not the same. It's not 7 and negative 7. It's not 19 and negative 19. It's not 143 and a negative 143. When you do your middle school math, you're going to see that the answers are slightly different. That's okay. It's just not a symmetrical graph. So we got x equals 1 and x equals negative 3 simply by undoing. Cool, on our last one, I'll go ahead and finish it up for you. We're going to go ahead and get rid of that extra junk. We divide by 0.25 on both sides, cancel it out, undo it, make it easier for yourself. X minus 5 to the 8th power. Grab your calculator when you're dividing by some decimals to make sure. And that takes us to a 256. At this point, we need to go ahead and take the 8th root. We're going to take the 8th root. Hey, that's even. We're going to go ahead and have 2 possible answers anytime that we got an even. Notice we didn't do it on the 5th power up there. That was odd. There's only one answer to those x to the 3rds, x to the 5ths, x to the 7ths, x to the 9ths. But whenever it's even, we're going to have a positive and a negative possibility. So our 8th root cancels out with our 8th power. We get x minus 5. We got the 8th root of 256. So I got the 8th root, 256. That takes us to a 2. Cool, we got a second possible answer. X minus 5 could also equal a negative 2. Welcome back to middle school math. We go ahead and add 5 on both sides. Boom, undo it. Sweet. 7 doesn't mean the other answer is negative 7 because we had parentheses here. Just go ahead and do that middle school math. You can do it. I believe in you. And we get x equals 5 plus a negative 2. There's a 3. And there's all your problems for solving equations with exponents when you are greater than just x squared and x cubed. Keep in mind, anytime you have an even exponent, we're looking for two possible answers, a positive and a negative. Anytime we have an odd exponent like we do up top, no worries, there's only going to be one possible answer for those problems.